All right. Happy Sunday, Mother's Day for you. Don't forget to wish your mom a happy Mother's Day. 8D, hopefully you gave those cards that we made to your mom this morning. All right, let's get to work. Here we go. Pre-assessment for adding, subtracting, multiplying, dividing rational fractions. Fractions with variables and sometimes monomials, binomials, and trinomials. So what we got here, first we have to evaluate what are we doing? Are we adding, subtracting, multiplying? We can't add those. Those can't be simplified. So we are multiplying. Notice we're multiplying all these things together. And so since they're multiplying, we can cancel things. So we're going to cancel that numerator with that denominator. We have 16 here and 12. So they both have factors of 4. So I can write 16 as 4 times 4. And 12 is 4 times 3. And y to the fourth, okay, well, I can write that. And I've got a y to the third. So you want to know what if I make y to the fourth, y to the third times y? That equals y to the fourth. And now we can cancel like with like with like. And now what are we left? We're left with a 4y in the numerator and a 3 in the denominator. 4y over 3 is going to be our answer. So we're constantly breaking them down. As long as they're being multiplied, we can break them down and cancel. Notice everything is multiplying. Everything is multiplying. The only addition that I'm canceling is complete. We've got Chewbacca arms in there. So as long as the addition is identical and complete, you're fine. You can cancel those. But like this, these are being added and subtracted. Yeah, there's common factors. Yeah, they're common A's, but this is all not multiplying and it's not a quantity. So we can't cancel this. We can never cancel a single thing that's being added and subtracted with a single thing that's being added and subtracted. So we're going to have to factor. Let's factor these and turn the addition and subtraction into multiplication. So I'm looking for a common factor of 12, negative 12, and then I can take out an A also. So that leaves me with 3A and plus 4. And if we want to check and make sure that we're correct, there's going to be two ways we can do that. We can distribute it back in. Negative 12 times 3 is negative 36. 8 times A is A squared. Negative 12 times 4 is negative 48. And then the A. Here's the other thing we could do, is you can find a common factor. So negative 36A squared gets broken into negative 1 times 2 times 2 times 2 times 3 times A times A. That's the prime factorization of 36. No, that's not it. 6 times 6, sorry. There's another 3 in there, sorry. I made a boo-boo. There you go. That's correct. Negative 1 times 2 times 2 times 3 times 3. Yep. And then negative 48, A has a negative 1. 2 is 24. 2 is 12. 2 is 6. 2 times 3 times A. I think I did that right. 16 times 3. Yep. Good. So now if we want to find the LCM between these two terms, we circle what they have in common. So they have a negative 1 in common. They have a 2 in common. They have another 2 in common. They have a 3 in common. And they have an A in common. So my LCM, that's what they, GCF, excuse me, not LCM, GCF, hello. I'm so used to LCMs, which we will do later, but GCF, sorry. Greatest common factor. That's what we're looking for. We're factoring. We're looking for the greatest common factor. Ooh, Mr. Mac hasn't been sleeping so much. Sorry. So we have negative 1 times 2 times 2. C is circle what they have in common. So negative 1 times 2 times 2 times 3 times A, which simplifies to negative 12A. And that's what we factored out, greatest common factor. And then Notice we had 3a left over and 4 left over, so that's how we factor. Sorry about that. I confused that with finding common denominators. We'll do the same thing for 18a to the third and 24a to the second. So we have 18a to the third, which is 2 times 3 times 3 times a times a times a, and 24a squared is going to be 2 times 2 times 2 times 3 times a, which is correct. GCF, circle what they have in common. They have a 2 in common. They have a 3 in common. They have an a in common and another a in common. So 2 times 3 times a, which equals 6a squared. So we're going to factor out a 6a squared from both of these, leaving us with 3a plus 4. Good. Now I turn this addition and subtraction into multiplication. Notice we have multiplication between these, and we can cancel these addition and subtraction because they're entire terms. They have Chewbacca. And then we have negative 12 over 6, which equals negative 2 in the numerator. A over a squared is a. So we end up with negative 2 over a. That's a good one. I like that problem. Yep, that's good. You could have broken up the negative 12a. You could have done this. We'll take our time and do that. You could have broken negative 12 into negative 1. No, you could have broken up into negative 2. Negative 2 times 6 times a over 6. Sorry, there's only one a. I'm getting sloppy. Sorry. Times a, and this would cancel, leaving us with a very clear answer of negative 2 over a. Number 3. All right, now is still addition and subtraction. We're going to do a times c. So we're going to factor this term. We got factors of 12. When the signs are the same, 1 and 12, 2 and 6, 3 and 4. Signs are the same, both are negative. That's my negative 7. So we get x squared minus 3x minus 4x plus 12. We'll factor out an x, you get x minus 3. Factor out a negative 4, you get x minus 3. X minus 3, x minus 4. So my numerator now becomes x minus 3, x minus 4. We'll factor this. Factors of 20 are 1 and 20, 2 and 10, 4 and 5. Signs are the same. Both are negative to make 9, which are negative 4 and negative 5. So my trinomial becomes x squared minus 4x minus 5x plus 20. Factor out an x, you get x minus 4. Factor out a negative 5, you get x minus 4. X minus 4, x minus 5 in the denominator. X minus 4, x minus 5. Now they're multiplying. Numerator cancels with the denominator, leaving us with x minus 3, x minus 5. We don't need parentheses around those. The vinculum represents that quantity. Now, again, we're going back to multiplication. Everything's multiplying, so we're going to cross cancel. We can break them all up. I would not multiply, but I would find common factors. 5 goes into this 3 times. 5 goes into this 7 times. 7 goes into 28 4 times. 4 goes into 24 6 times. So, and then we got 3 and 6. So 3 and 6 becomes 2. So I have a 2 in the denominator. We got x squared and x. So this x cancels with one of those x's, leaving me with x. We got y to the fourth, they cancel out. You got a and a squared, so you got an a left over. You got b to the third and 4 of them here, so you're left with a b. So you have in the numerator, you have ab, x, abx, In the denominator, you got a 2. That's it. So ABX over 2. Okay. You can break all that up and show the prime factorization and cancel, but I'm pretty good at keeping track of stuff. All right, we're going to have to factor each of these. So you got factors of -6, -6, which is 1 and 6, 2 and 3. Signs are different. Bigger is positive. Gives me my 1. You get x squared minus 2x plus 3x minus 6. Factor out the x minus 2. Factor out the 3, x minus 2. X minus 2, x plus 3. That's going to be in that numerator, so we'll put that up here. X minus 2, x plus 3. You got factors of -12, which are 1 and 12, 2 and 6, 3 and 4. Signs are different. Bigger is negative. Bigger is negative. These are positives because they're different. Gives me my -1. So we have x squared plus 3x minus 4x minus 12. Factor out the x plus 3. Factor out the -4, x plus 3, x plus 3, x minus 4. X plus 3, x minus 4. That's not a very good 4 right there. Let's just clean that up, just in case somebody wants to look at the notes. All right, we're going to go top right. So top right is factors of -20, 1 and 20, 2 and 10, 3, no, 4 and 5. Signs are different. Bigger is positive. This is my 1. So we have x squared minus 4x plus 5x minus 20. Factor out an x minus 4. Factor out a 5, x minus 4, x minus 4, x plus 5. X minus 4, x plus 5. Last one, factors of 4. We see that that's actually a binomial square, but we can show that it'll still work. Factors of 4 are 1 and 4, 2 and 2. Signs are the same. Both are negative, giving me -4. X squared minus 2x plus 4. X minus 2, factor out -2, x minus 2, so we get x minus 2. That's not very clean. X minus 2, x minus 2. Now let's start canceling. X minus 2 in the numerator cancels with the denominator. X plus 3 in the numerator cancels with the denominator. X minus 4 cancels with the x minus 4, leaving us with x plus 5, x minus 2. Good one. All right, I would factor first. Okay, I'd factor before we start flipping and changing and all that stuff. So we got -6. A times C is -6. Better write it down here. -6. 1 and 6, 2 and 3. Signs are different. Bigger is positive. Bigger is positive. Bigger is negative. So we get that. So we get 2x squared plus x minus 6x minus 3. We'll factor out an x. 2x plus 1. Factor out a -3. 2x plus 1. 2x plus 1. X minus 3. Okay. So 2x plus 1. X minus 3. Just checking. -3. That's +2. We have a middle of x, -6x. Yes, good. So let's do this one. 3 times 2 is 6. So factors of 6 are 1 and 6, 2 and 3. Signs are the same. Both are positive. Gives me 7. So we have 2x squared plus x plus 6x plus 3. Looks very similar. Factor out an x, you get 2x plus 1. Factor out a I put a 6 there for some reason. It should be a 3. Factor out a 3, you get 2x plus 1. 2x plus 1, x plus 3. 2x plus 1, x plus 3 divided by, and we can do these, that's negative 40, which are 1 and 40, 2 and 20, 3 no, 4 and 10, 5 and 8. 6, no, 7, we're good. Signs are different, bigger's negative, and it equals negative 3, which is this. So we get 2x squared plus 5x minus 8x minus 20. Factor out an x, you get 2x plus 5. Factor out a negative 4, you get 2x plus 5. 2x plus 5, x minus 4. So 2x plus 5, x minus 4. Just checking. Yep, good. We'll do this one. That's negative 30. 1 and 30, 2 and 15, 3 and 10, 4 no, 5 and 6. Signs are different. Bigger's negative to get 1. That's my negative 1 right there. So 2x squared plus 5x minus 6x minus 15. Factor out an x, 2x plus 5. Factor out a negative 3, giving us 2x plus 5. 2x plus 5, x minus 3. 2x plus 5, x minus 3. Now, I'm going to change from division to multiplication by keep 2x plus 1, x plus 3, switch and flip. So this now, denominator now becomes the numerator. The things in the numerator now become in the denominator. Whoa, sorry. Oh, I don't know what happened there. Minus 4. Now we can cancel. Everything's multiplying. 2x plus 1, 2x plus 1. No. Those don't cancel. That's too bad. Let's get those parentheses in there. That cancels. That cancels. Oh, wow, that's too bad. So let's check. Let's make sure that we did it correctly. So, because I feel like there should be more things canceling. So we got negative 6 here, and that's correct. Negative 5. So does that make negative 5? Yep, that's negative 6. Good. That's supposed to give me positive 7. That's positive 7. That's correct. That's 1 and 6 makes 7. Denominator, negative 1. Yep, that's negative 1. That's correct. And let's see this one. That is negative 8. Positive 5 makes negative 3. That's negative 20. Yeah. Something tells me I was supposed to end up with something different. I feel like I made a mistake somewhere. I could have made a mistake when I copied down the problem. Okay, so this is what we got, though. Everything is correct. I factored correctly to my best of knowledge. That's negative. That's positive. I'm just checking, right? Just if you feel like something's wrong, keep checking, because sometimes it's so obvious and it's right there, and you don't notice it. But I'm pretty sure I'm correct here. So we're gonna move this down, and I'm gonna have to fix the answer key because I did not have that as the answer in the answer key. So the answer is going to be x minus 3. Oh, yes, it is. Sorry. I remember this. This is correct, actually. I do remember this. Quantity x minus 3. I do remember that. It would have been nice if it was... Yeah, this is actually correct. That's what the answer key. Whew. Okay, that's correct. Good. Sorry about that. I questioned myself. And it's okay. If you question yourself, go check it some more. You know? All right, now we're adding and subtracting. So now I need common denominators. So we have common denominators. So having common denominators allows me to put all of the things in one numerator, and then we just bring across the one common denominator. Now we're going to combine like terms. This gives us negative 5x, which gives us 6x over 4xy. Now we should pay attention to things being multiplied. The x's will cancel. The 6 becomes a 3. The 4 becomes a 2. And we're left with 3 in the numerator, 2y in the denominator. I like that problem. That's a good problem. All right, now we have to find least common multiple. So LCM of 12a, which is 2 times 2 times 3 times a, and 9a, which is 3 times 3 times a. So LCM, different from GCF. The C still talks about circle the common. So they have a 3 in common and an a in common. And then the leftovers. That's the different thing about. So leftovers are 2 times 2 times 3, which all simplifies to 36a. 36a. That would be my common denominator. 36a minus 36a. Now we have to find congruent fractions. So 4a minus 5 over 12a is congruent or equal to how many? What over 36a? So we ask ourselves, what times 12a would give us 36a? Times 4. When we multiply, we have to multiply everything. So we're going to distribute that to both of them, giving me 16a minus 20. And now we're converting 3a minus 2 over 9a into 36a's. And what do we multiply 9 to get 36? 9a to get 36a times... No, that's not correct. Times 4. 12 times 4 is 36. Yep. How many people caught that? Did you catch that? Did you catch that? Did you really catch it when I was doing it? So let's go back. Sorry. We're not multiplying by 4. We're multiplying by 3, Mr. Mac. 3 times that, which again distributes, is 12a minus 15. 12a minus 15. Sorry. Again, haven't slept much these last 4 days. 3a minus 2 over 9a equals 36a. This one we multiply by 4, giving me 12a minus 8. 12a minus 8. Now we have like denominators, so we can put it all over the same denominator, 12a minus 15. Now this is the tricky part. Minus this. So 12a minus a. That's the tricky part. That's the step that students get wrong. We would have to distribute this negative because we want the opposite of these two values. Simplifying to 12a minus 15 plus minus 12a plus 8 all over 36a. The 12a and the negative 12a cancel. Negative 15 and 8 gives me negative 7 over 36a. Okay, good. Don't think I made any mistakes there. All right, now these are unlike denominators. We have to find the common denominator. Now this is adding and subtracting, so we need to factor this. We're going to factor that. That's factors of 8. So that's going to be 8 and 1, so 4x squared plus x plus 8x plus 2. That makes 9x, so that's where we factored. You factor out an x, you get 4x plus 1. Factor out a 2, you get 4x plus 1. 4x plus 1, x plus 2. That's that new denominator. I like writing it afresh, anew. 3x plus 6, and then this becomes 4x plus 1 and x plus 2. Okay, now when we find the LCM of these, because they're not common denominators, you have 4x plus 1. A lot of students want to break this up to 2 times x plus 1. This is adding and subtracting. You can't break that up into prime factorization. Here you have 4x plus 1, x plus 2. So breaking that up is going to look like this, times x plus 2. Let's move this scratch work down a little bit. So when we find the LCM, well, what do they have in common? They have a 4x plus 1 in common. And then what do they have left over? They've got the x plus 2 left over. So that's going to be my common denominator. 4x plus 1, x plus 2, and I'm going to write equivalent fractions to both of those. 4x plus 1, x plus 2, and now I got to write an equivalency. So again, let's move you guys down a little bit. 3x minus 4 over 4x plus 1 equals what over 4x plus 1, x plus 2? So what's this missing? This is missing an x plus 2. Excuse me. Here's the other tricky part of this. When we multiply this, these are quantities. You gotta FOIL. So you're gonna have to double distribute. So 3x times x is 3x squared. 3x times 2 is 6x. Negative 4 times x is negative 4x. Negative 4 times 2 is negative 8. So that simplifies to the equivalency of 3x squared plus 2x minus 8 plus 3x plus 6. Okay, now we have like denominators. Now we can put everything over the same denominator. So I'm taking my 3x squared plus 2x minus 8 plus 3x plus 6 all over 4x plus 1, x plus 2. 3x squared doesn't have a pair like term. 2x and 3x makes 5x. Negative 8 and 6 makes minus 2. Makes minus 2. 4x plus 1, x plus 2. Now we're going to a times c that. We got to see if that's factor. We can't cancel things unless it's multiplication. So we're going to try to make this multiplication. So factors of negative 6 and make 5. Yep. We got negative 6, which is 1 and 6. Signs are different. Bigger is positive. So that's my 5. So 3x squared minus x plus 6x minus 2. Factor out an x. 3x minus 1. Factor out a 2. 3x minus 1. 3x minus 1. X plus 2. So this becomes in the numerator 3x minus 1 x plus 2 over 4x plus 1 x plus 2. Ooh, all this work finally paying off. And my final answer is 3x minus 1, 4x plus 1. Can't cancel anything. That was a long one. That was a super long one. Well worth it. I think, no, this might not be the last one, but we'll see. Let's factor this. So you have x minus 3 minus 2x and x plus 4 minus 14. I'm going to just let you know that factors to plus 4 minus 3 factors of 12 when subtracted, leaving me with 1. Okay, now what's my common denominator is going to be x plus 4, x minus 3. I see that already. I know that. X plus 4, x minus 3 minus, well, this isn't going to change because it's already x plus 4, x minus 3. What's this Whoa. What's this missing is an x plus 4. So I'm going to take that numerator, multiply it by x plus 4. That's the way we found an equivalent fraction. This is missing for this is an x minus 3. So we'll take this 2x and multiply it by x minus 3. And there you have it. Now we've got like denominators. These are all my numerators. We're going to distribute that while we write it all over the same one. So that's x squared plus 4x. I'm going to multiply negative 12x or negative 2x times these because I'm going to attach that negative so I don't have to do it multiple times. That's negative 2x squared. That's positive 6x. Right? Negative 2 times negative 3 is positive. And then you got minus 14 all over x plus 4, x minus 3. Let's combine like terms. That's 3x squared. That is plus 10x. And that's it, minus 14 all over x plus 4, x minus 3. What's that, 42? 42, negative 42, factors of negative 42 are 1 and 42, 2 and 21, 3 and 14, 4 no, 5 no, 6 and 7. Signs are different. Bigger's positive to make 10. None of those make 10. So that's 41, that's 19, that's 11, close, and that's 1. So this is actually my answer. And I just make sure that I multiplied 3 times 14 correct. That's 12, 42. Yep. And so that's my answer. All right, last fun extra problem. So as I've mentioned, there's 2 ways we can do it. We can tackle the numerator, and we can just simplify this, turning this into 6 over 2. We can simplify this, making this 16 over 2. You have like denominators, etc. Or you can multiply everything. This is the high school way. You can multiply everything by 2 over 2, which is a value of 1. When we multiply this numerator, we have to do to both terms. So that equals 6 minus 5. 2 times 3 is 6. 2 times 5 over 2, the 2's cancel. That's why I did that. And then when we distribute here, you get 16 minus 7, because 2 times that gives you negative 7. This gives me 1. This gives me 9. 9. 1 over 9. 1/9. Is it really 1/9? I don't remember getting that as an answer. Let's check it. Make sure that's correct. That's 16. That's negative 7. Yeah, 1/9. And that's it. You are done. Nice job. Keep studying. Appreciate you guys.